Use the Faro scan arm to laser scan a votive figurine in metal. So here we're using a GeoMagic Wrap 2017. We've got the Faro drivers, and we've got a plugin using the digitizer plugin for the Faro plugin 17.0, the 2017 version. That talks between GeoMagic Wrap and the scanner drivers. Once we're into Wrap, we go into Capture and click the Scan button. The Faro plugin comes up, and under Scanning Options, we click Start Capture. And we come over to the arm, and the arm has a green button, a Start Pause, and a red for Stop. So we'll hit the green button to start. It projects a blue laser and a red laser. The red laser crosshair, we want to keep intersecting the blue laser for height, so we're not too far from the object. And then we just click the record button, and we start to acquire data. So we're going to sweep the beam, and the sensor is looking at the deformation of the beam. So we're going to try to cover as much of the object as we can from this angle. Trying to keep the distance so that the crosshair is right on the blue line. And then as that comes across, we can check our data on the computer, and it looks pretty good. I'm changing the orientation of the laser to try to get any shiny spots we can from other angles. And then when I'm done, I'm going to hit the red button to stop, magnet the arm back, come over to the computer and click OK on the Faro plugin, which will then save that scan, and we can start another one. So then we'll start another scan and change the object's orientation. If we hadn't started another scan, it would reference the same geometry, so every time we change the object's orientation, we'll start a new scan. If we leave it fixed, we can just start again. Then we come in here and start capture again. Pick up the arm, press the green button, and we'll get the other side. Making sure just to get anything we didn't get from the other angle. Then same thing. We'll say OK, and now that comes in. If we hide the first scan, now we have a second scan. Looking pretty good. And now we're going to have to get the back. So I think I'll turn it over. Just like that. And then scan again. Start capture. Come in. Hit the record. Pass over the back of the object. Gotta get over to get the tail. On the side. Okay, and now I'm going to try to get one more angle of it standing up. I think this will stand. Yep. Record, and then we'll try to get the whole front here. And I'm sweeping the laser evenly to try to get nice smooth data. And if I'm getting reflection, so I'm missing a part because this is metal, I'm coming over just a couple passes to try to get different angles. Okay, and I think we have enough to construct it now. So we're gonna save the project. Okay, so now we've got all of our scans, and we're going to process them. Okay, so now we're going to process the scan we just acquired. So we've got 4 scans that came in, and the first thing we're going to do for each scan, we're going to remove any parts that aren't the object. And to do that, I'm just going to use the line selection tool, and I'm going to select a bunch of pieces and remove stuff that is not part of our scan. So for us, that's mostly the table. So just come in here. And we can cut too much, we just don't want to cut too little, because we have some coverage from the other scans. We want to remove anything that's not definitely our object. So most 3D scanning tools have a way to do a similar methodology. Here I'm just going to change my angle slightly. And it's all about manipulating the model so that you can see the ground clearly, or whatever is not your object. That looks pretty good. Now we've just got the faces that are the bird. Oh, we got a little piece here. Looks great. Now we'll hide that, and we'll go to the second one, and same procedure. I'm going to just manipulate it so that it's easier to select. Come around here. Oop. That looks like just the bird. And then we'll hide, go to the next one. Same procedure, find the angle. Now you could use a base cutoff tool to select the base plane. This is just, I think, the fastest way to do this quickly. And we want to make sure we don't leave anything that's not the object. It's okay if we actually cut into the object a little bit, because we have most of the object covered from multiple angles. And here we got to get that piece of floor out from in between the feet. Okay, maybe another little bit right below that toe. Great. And then we have one more angle, so we'll hide this and come into our last angle. And come in, do the selection. Right below the tail. And I'm using the view selector there. When I get a little lost, just reset my view quickly. The important thing here is changing your camera angles to make sure you can see what you're selecting clearly. Just come right around here, grab that. Some of these little outliers I'll just tidy up real quick. And I'm using the scroll wheel to change my camera angle and zoom in and out. So I click with the scroll wheel here to rotate. Okay, so now we've got all 4 of our scans with just the duck, and now we need to align them. So we're going to do alignment of our 4 scans. So we've got the 4 scans with the bottoms removed. We're going to select all the scans, click manual registration, select scan, the first scan and the second scan, which will load them into the 2 frames. And we see all of our scans piled up on each other here. So for these 2, we want to find points of overlap that we can use to align them. So we're going to just click some points as close as we can and try to get a good alignment out of that. Oop, I lost my second point right here. And then our third point should allow this to align, and I think the duck bill is a good one. And there we go. Looks like they just snapped together. And those look to have pretty good alignment. so now we will say next, and I'll grab two different scans. So this one looks like we have mostly the back of the bird, so we'll click the wing, and the skull, and maybe the edge of the tail on the corner. Does look pretty well aligned. I might get 1 or 2 more points just to get a better alignment. Now this bubble on the shoulder is very easy to click. That should help square it a little bit. And then maybe, is there anything on the front? No, maybe on the top of the nose? Use like point on the top of the nose. And that helps, if we spread out the points, helps get a better alignment. Next. Now, group 1 and group 2, we want to overlap. And this is now we're building up some geometry. This should be a little easier. So we're going to click right below the eye, and right below the eye. And let's see. You see one of the contours on here. A little fold in the wing. The toe. Seam in the other wing. And then let's see, do we have anything over here? The other toe. There we go. Grab something right in here. Now, there's not quite the alignment that I want there, and it'll help some of it in the next step, but let's see if we get it just a little better here. Maybe using the edge here. Okay. So, that's our final alignment, and it's good. It's not perfect, but I think we'll get it right in the registration. So I'm going to save. Okay, and now we're going to do a global registration of all of the scans. Okay. All right, starting to look like an object here. Okay, hold on, coming back to these. We're going to just do a merge first. And then we'll merge, fill holes, remesh, mesh doctor. Okay, that's a pretty good merge. Then we want to fill all. It's gonna find a couple of holes I had there from my gaps. And actually that makes sense. So those holes had to do with our acquisition. The scanner can approach easier from the right side based on how we have this set up, and my right side is perfect. To get this object even more perfect, I should turn it over and do another acquisition. So since we have the object here, and our gaps are all on one side, I know that's a result of the scanner ergonomics. But for the demo, we can just fill, and now we've got them. And then we're going to, now that we've got all of our scans merged into a polygon and all the holes filled, we're going to do the mesh doctor. And we'll have it do the auto repair, the full auto repair. There we go. That looks pretty good. We're going to hide and hide. Okay, there we go. We were seeing two things. We were seeing our scan plus our mesh. So there's our actual resulting mesh that looks much better. And so now, if we want to work with this object further, we have it at 634,000 triangles. We can export that. I should be able to export this as a mesh. Save. Save. And then we're going to do an STL binary to make it smaller. Save. And then we'll save the whole project. And final step, I always like to open it in a different program to make sure that it worked. If we have our duck figure here, can open with, actually hold on, I want this one, open with Microsoft 3D Viewer. And there is our polygon mesh of the duck, looking pretty good. We can give it some color, make it look kind of like the real one. There we go. So you're definitely able to see some of the surface detail. It's very hard to pick up on the actual object. You can see some of the pitting on the back. And that light really helps you see some of the texture as we move around. Very high resolution, more than we can get with our structured light scanners currently. Some of these lighting effects are fun to try to see different texture, surface detail. So here we're only getting a measurement, we're not getting color, but we can see a lot of surface detail by playing with different lighting. I think it's actually easier with the gray. There, we can really see some of the marks. And here we can even start to look for tool marks and wear patterns. There's a lot of high resolution data there. Like the surface of the moon.